2.1 Basics of Functions and Their Graphs. Determine whether the relation is a function. Give the domain and range of the relation. So again, the function is a specific type of relation. Okay, so we plug in a 2, we get a 3, we plug in a 5, we get a 6, we plug in a 7, we get a 7. So this looks good. Sorry, here looks good, right? So 2 only goes to one number, 5 only goes to one number, 7 only goes to one number. Okay, so this is a function. So I put yes, it's a function. Yes. Okay, what about domain? Oops, domain. Again, whenever we see domain, we're looking at the x values of the domain. Whoops. Okay, so the x values are a 2, a 5, and a 7. Well, what about the range? Okay, well, the range are all the y values, right? So again, x domain, y range. And the range is going to be 3, 6, 7. Okay, now let's look at the next one over here. We plug in a 2, and we get a 3. We plug in a 2, we got a 4. We plug in a 5, we get a 3. We plug in a 5, we get a 4. So this is not, because, as you can see, we have 2. Sometimes when we put the 2 as an input, we get a 3. And sometimes when we put the 2, we get a 4. Sometimes when we put a 5 as an input, we get a 3. And sometimes when we put a 5 as an input, we get the 4. So this is not a function. Okay, but it still has a domain and range. Okay, so domain has to do with the x values, and the x values on this are a 2 and a 5. Now the range values are the y values, and the y values are a 3, 4, 3, 4. Okay, I want to point something out. If they repeat, you don't repeat them, right? You only write each element once. So technically, you have a 3 and a 4, and it repeats 3, 4, so the range is just 3, 4. We don't want to repeat it, otherwise it's considered wrong. Okay. Now, how about the next one? We plug in a 5, we get a 6. We plug in a 1, we get a negative 9. We plug in a 4, we get a 4. We plug in a negative 9, we get a negative 9. Okay. Now, this might be confusing. All we care is that every time we plug in a different x, right, we get a different y. Okay, so the same x cannot go to two different y's. Okay, so this is a function. And let me graph this really quickly, kind of show you what I mean by this. I realize this might be confusing. Okay, so this is what I'm doing over here. Okay, so let's say we have a 5, we have a 1, we have a 4, and we have a negative 9. Okay, then we have a 6, and we have a 4, we have a negative 9, and that's it. Okay, so 5 goes to 6, check. Notice there's only one line going from the 5. 1 goes to negative 9, check. Notice there's only one line going from the 1. We say 4 goes to 4, check. We only have one line going from the 4. And we say negative 9 goes to negative 9. That's okay, because there's only one line going from the negative 9 on the left side. That's why this is still a function. We don't care that two different values of x's go to the same y. So a function would be like a price. The price is a function of the object, or the price is a function of the item you're purchasing, right? So if I go to the store and I try to buy a Snickers, it should only spit out one price. But I could have two different candy bars with the same price. I could buy two different pencils with the same price. I could buy two different pens with the same price, right? Yeah, exactly. So the point being is that there's only one price per item, but different items might have that same price. And therefore, price is a function of the item that you are purchasing. I know that's a little abstract, but I'm just trying to point out that this is okay. It's okay that you plug something in, right? You plug in an x value and it only gives you one y value, but you plug in a different x value, it gives you the same y value. This is still a function. Functions exist in real life. They're pretty common. Okay, so anyways, it turns out that yes, this is a function. Yes, it's a function. I'll give you better examples on functions later on. So yes, it's a function. Remember, the domain has to do with x. I know I'm repeating myself, but I really want you guys to remember that. Okay, domain has to do with the x values. So it looks like I have a 5, I have a 1, I have a 4, and I have a negative 9. And then we do range, right? Range, and range has to do with the y value. So we have a 6, we have a 4, and we have a negative 9, right? let's move on to the next problem. So we're going to evaluate the function of f of x is equal to 7x plus 9 at the given value of the independent variable and simplify. Okay, so all this is really saying is I'm going to go back through this original equation, but wherever I see the x value, I'm going to plug in whatever it says there. So in this case, instead of x, it says 8. So it's 7 times 8 plus 9. 7 times 8 is 56 plus 9. 56 plus 9 is 65. All right. So now let's go on to the next one. So in this case right here, wherever I see x, instead of writing x, I'm going to write x plus 9. I know that looks weird, but we plug this entire thing in instead of x. So now we distribute it. 7 times x is 7x. 7 times 9 is 63. 63 plus 9 is 72. Over here we have a negative x, so wherever we saw the x before, now we're plugging in the negative x plus 9. 7 times negative x is a negative 7x plus 9, and that's it. Okay, so we're going to evaluate the function of fr equals square root of r plus 2 minus 2 at the given values of the independent variable, and we're going to simplify. Same kind of thing. So wherever you see an r, that's where you're going to plug it in. So we're going to plug it in right there, right? So we're going to say square root of r, or in this case, negative 2 plus 2 minus 9. 2 minus 2 is a 0. Square root of 0 is 0. 0 minus 9 is negative 9. We go on to the next one, square root of, and so that's where we got this, right? We put the negative 2 there. Here in this case, we're going to put the 62 plus 2 minus 9. 62 plus 2 is 64 minus 9. Square root of 64 is 8 minus 9. 8 minus 9 is negative 1. All right. So on the next one, we are going to plug in x minus 2. So this one's going to look a little bit weird. So it's x minus 2 plus 2 minus 9. And we would say minus 2 plus 2 is 0, or it just goes away. They cancel each other out. And keep the minus 2 on the outside. All right, so we're going to evaluate the function f of x is equal to 4x squared minus 2 at the given values of the independent variable and simplify. Okay, so wherever we see x is now, which there's 2 different places, that's okay. We're going to plug it in. So in this case, we're going to say 4 times 5 squared minus 1 on top, and then we're going to say 5 squared on the bottom. Okay, 5 squared is 25. Okay, and 25 times 4 is 100. All right, so now we're going to plug, so this is where we plug the 5 in there, and we plug the 5 in right here. Okay, so we have to plug the negative 5 in there, and we have to plug in the negative 5 on the bottom. So now we have a negative 5 squared minus 1, and the bottom we have a negative 5 squared. Okay, so what we end up with is 4 times 25 minus 1, which is the same as 100, minus 1, which is the same as 99. And on the bottom, we end up with a 25. Let me write that over here. I know that's super small. Okay. Now notice that when you take 5 and square it and you take a negative 5 and square it, you end up with the same result. That's not an accident. That's correct. Okay, so now we're going to plug in a negative x. So we're going to have 4 times negative x squared minus 1 over negative x squared. Now what happens when you square the negative x? It just turns into a positive x squared, right? Again, a positive x squared. So you end up with that right there.